Hello and welcome to this in my series of videos about logic. In the last video we talked about simple statements and their negations. And in this video we're going to look at a couple ways you can take two simple statements and put them together to make a compound statement using words like and or. First of all, an and statement, where you say something is true and something else is true, is called a conjunction. And in order for the whole thing to be considered true, both parts have to be true. So for example, if I say, I am wearing socks and shoes, both parts have to be true. I have to be wearing socks and I have to be wearing shoes. If I'm just wearing one or the other, or neither, that's a false statement. But if I am wearing socks and I am wearing shoes, it's a true statement. Here are some more examples of conjunctions, that is, and statements. Today is Monday and tomorrow is Tuesday. Now, that might be true or it might be false, depending on what day you happen to be watching this video. Roses are red and violets are blue. If I'm asserting that as a true statement, I'm saying that both parts of it are true, that roses are red and that violets are blue. Joe Biden is the President of the United States and Homer Simpson is the King of England. That's an example of a false statement. It's true that Joe Biden is the President of the United States, but it's false that Homer Simpson is the King of England. And for the whole thing to be considered true, both parts have to be true. Since they aren't, that whole compound conjunction is false. Michael is tall and bald. Now, that's a conjunction, and the two simple statements that make it up are Michael is tall and Michael is bald. So when I say Michael is tall and bald, I'm saying that Michael is tall is true and that Michael is bald is true. Fido and Spot have fleas. So the two simple statements I'm putting together are Fido has fleas and Spot has fleas. I'm saying that both of those are true. And sometimes we use the word but instead of and, but logically it means the same thing. So I could say, Leroy is younger than Bruce, but he's older than Jerry. So logically, that means the same thing as Leroy is younger than Bruce and he's older than Jerry. I'm saying that both parts of that are true. It's cold outside, but the sun is shining. I'm saying that it's true that it's cold outside, and it's also true that the sun is shining. So conjunctions are and statements. You can also have or statements, and the fancy word for those, we call them disjunctions. So this is a little different use of the words than you may be used to in like English grammar, where the words and or are both considered conjunctions. But in logic, a conjunction is an and statement. The whole statement that says that something is true and something else is true. And then an or statement, a whole statement that says that something is true or something else is true, is called a disjunction. Now, in ordinary language, when we use the word or, sometimes we mean one thing or the other thing or both, and other times we mean one thing or the other thing, but not both. Like, if you go to a restaurant and they say, if you order an entree, you get soup or a salad. You can pick one or the other, but you probably can't have both. But if you go to a job interview and they say, we'll only consider people who have a degree or relevant work experience, if you have both of those things, I'm pretty sure they will consider you. So in ordinary language, sometimes or means one or the other, but not both. We call that an exclusive or. And sometimes it means one or the other or both. We call that an inclusive or. And here in logic, we're going to assume that when we say or, we're talking about the inclusive or, the one that means one or the other or both. There's we could consider an exclusive or to be a different sort of statement or a different sort of combining simple statements. But for now, we'll just focus on the meaning of or that means one or the other or both. So if I say, I am wearing socks or shoes, that would be true if I were wearing just socks but not shoes. It would be considered true if I were wearing just shoes but not socks. And it would be considered true if I were wearing both socks and shoes at the same time. The only time that or statement would be considered false would be if I were wearing neither socks nor shoes, if both parts of that were false. So some more examples of disjunctions would be Joe Biden is the President of the United States or Homer Simpson is the King of England. Now, that is a true statement. At least right now, as I'm recording this video, Joe Biden is indeed the President of the United States. If you happen to be watching it sometime in the future when he's no longer president, then that would be a false statement, unless somehow Homer Simpson has been made the King of England. Frank has your hat, or he gave it to Carolyn. There's an example of a disjunction. I'm saying that one or the other, or possibly both, but in this case I don't think it could be both, but it would still be considered a true statement if somehow both parts were true. Lois went to the movies or the ball game. So I'm saying that that would be true if Lois went to the movies, and it would also be considered true if Lois went to the ball game. The only time it would be false is if neither part is true, if Lois didn't go to the movies and also didn't go to the ball game. Monica or I will be working tomorrow. So that would be true if Monica's working tomorrow. It would be true if I will be working tomorrow. It would still be true if we were both going to be working tomorrow. But it would be false if neither one of us was working tomorrow. Now let's talk about how we can take a logical statement and translate it into symbols so that we can focus on the logical structure and not worry about the exact wording and exactly what's going on, and just focus on how things relate logically. So for one thing, in logic, we use letters to stand for simple statements. Kind of like how in algebra, we use letters to stand for numbers. So X might stand for 3, or H might stand for 17. In logic, we might use a letter like P to stand for it is raining. Then the symbol for and looks like this. It's an up pointy thing. So if the letters P and Q both stand for simple statements, the conjunction of those, P and Q, would be written like this. And if it helps you to remember that, notice that the symbol for and looks like a capital letter A, but without the part that goes across in the middle. The symbol for or looks like the symbol for and turned upside down, like this. So it looks sort of like a V shape. So this would be P or Q. And I should maybe mention that these are probably the most commonly used symbols for and or, but there are other symbols that other people sometimes use instead. Certain programming languages for computers might use like an ampersand for and a vertical line for or some other symbol like that. But these are the symbols that we will be using. They're the ones that I think are used most commonly. And an additional advantage to these particular symbols is if you are familiar with set theory and unions and intersections of sets, these symbols should remind you of the symbols for union and intersection. If you don't know about that, don't worry about it. But if you do know about that, notice that the symbols for or and, they're pointy instead of rounded, but they look sort of like the symbols for union and intersection. So or is like union. To be in the union of two sets, you just have to be a member of one or the other of those sets. And the symbol for and looks like the symbol for intersection, only pointier. To be in the intersection of two sets, you have to be a member of one set and the other set. So if that helps you remember, great. If not, or if you haven't studied that, don't worry about it. And the symbol for not is this wiggly looking thing. And again, other people use other symbols, but this is one that's commonly used. So this is how I'm going to be writing the negation of a statement, by putting that wiggly thing in front of the statement. So if P stands for some simple statement, that wiggly symbol in front of P will stand for not P, the negation of P. So let's do some examples of translating from words into symbols. In these examples, I'm going to use P to stand for the simple statement, it is cold, and Q will stand for the simple statement, it is raining. So to write it is cold or it is raining, that's P or Q. In symbols, that looks like this, P or Q. What about it is not raining? Remember, Q stands for it is raining, so this would be the negation of that. The not of that. Not Q. So the wiggly not symbol in front of the symbol that stands for it is raining. So there's it is not raining. What about it is cold and raining? See that and there? This is a conjunction, an and statement. It is cold and it is raining. P and Q. And what about it's raining, but it's not cold? Remember I said but is logically equivalent to and. So it's raining, Q, and it's not cold, not P. So that looks like this, Q and not P. Let's try some the other way, going from symbols to words. In these examples, P will stand for the statement, Ed is wearing pants, and Q will stand for the statement, Kim is wearing shoes. So this would be not P, the negation of P. So that would be, Ed is not wearing pants. What about this? P and not Q. Ed is wearing pants and Kim is not wearing shoes. Okay, what about this? P or Q. Ed is wearing pants or Kim is wearing shoes. What about this? Not P or not Q. Ed is not wearing pants or Kim is not wearing shoes. Well, now that we know how to translate from words into symbols, or vice versa, we can talk about how to take an expression in symbols and figure out the logical value of the whole thing, how to sort of evaluate that the way we might evaluate an algebraic expression. And that will be the subject of the next video. See you then.